Okay, today's video is looking at solving log equations. So we want to remember the log properties, the product, quotient, and power property, because those are going to help us, rewrite some of our logs when we need them. So when we have logs on both sides of our equation, like we do here, we can set the arguments of the two logs equal to one another. So we're basically just getting rid of the logs itself. And then we can solve for our variable. So subtract 2x. I get 3x equals 9. Divided by 3. X equals 3. We do with these have to plug x back in and check because we need to make sure that when we plug x in, we don't get a negative log on either side. So for my check, do 5 times 3, that's a positive 15, good there. 2 times 3 plus 9 also gives me a positive 15, so all good there. Okay. Now for one like this, where we have two logs, first we want to condense them at all possible. So I see there's a plus in the middle, so that means I can multiply together. So I have log and then 8 times x equals 2. And then it's in log form now, and in order to solve, I'm going to need to rewrite it in exponential form. So I have to remember that the base here is 10. Whenever I don't see a base, it's assumed to be base 10. And then I'm going to rewrite it. So this is our b, this is our x, and that's our n if we think back to the different forms. So b to the x equals n, which is 8x. And then now we can solve. So 10 squared is 100 equals 8x. And then if we divide both sides by 8, we can simplify. So let's say we realize 4 goes into both of them first. We get 25 over 2 equals x. Okay. Same thing in the next one. I see two logs. So I need to condense them to write them as 1. And the minus sign tells me that I'm going to use the quotient rule. So I have log, this is base 10, x over 2 equals 1. Then again, I'm going to label my b, my x, and my n so that I can rewrite. So I have 10 to the first power equals x minus 2. 10 to the first power is just 10, so to get x by itself, I'm going to multiply 2 on both sides. I get 20 equals x. And something we didn't do on the last problem, but we need to do on this one, is we need to check. So I'm going to take the 20 and plug it in, which is just x here, so that's positive, so we are all good. Okay. Alrighty, so remember this negative 2 is being multiplied by the log, so we can undo multiplication by dividing both sides by negative 2. And then now we have just one log on both sides, and I can label the b, the x, and the n, and I can go ahead and rewrite. So b is the base, so 5 to the negative 1 power equals 7x. And remember from our exponent rules, whenever we have a negative, we move it to the denominator. So this is like 1 over 5 equals 7x. We're going to divide both sides by 7, which gives us 1 over 35 equals x. Okay, and then last two examples here. In this one, we need to make sure to isolate the log by itself before we can rewrite anything. So I'm going to add 10 to both sides. gives us 0. We have 1 log on each side, so I'm going to label my b, x, and n. Okay, so 3 to the 0 is 1. Then to get n by itself, we subtract 3 on both sides. We get -2 equals n. So again, we're going to plug the back in to check. So check. -2 plus 3 gives us a +1. Great. All right. And then same thing here. We need to combine to get 1 log on both sides. So we're going to multiply 6 into x squared. Okay, and now since we have log 5 on both sides, we can basically just cancel them out and set the 2 arguments equal to one another. So 12x squared equals 48. Divide both sides by 12. X squared equals 4. To get rid of the square, I take the square root of both sides. Okay, x equals plus or -2, because remember, -2 times -2 is a positive. So I want to check both of those values. So over to the side, I do 2 times 2 squared, which is going to be positive no matter what. And 2 times -2 squared is also going to be positive. So that's a quick review on how we solve some log equations.